This is packet 17, problem number 3, and we are talking about differentials. So the dy and the dx are called differentials. And we want to know something about what the differential of y would be. What would the change in y be if the change in x is 0.5? So if it's a half. So on the first part, I have g of x is 8 over x. I can look to find the derivative of x, okay? But another notation for the derivative of x is dg dx. And my function is, again, 8 over x, which I can think about as 8 times x to the negative 1, which would help us make what our derivative, help us find what our derivative is a little easier in that form. So we multiply our exponent times the coefficient, get negative 8, take and lower the power on the exponent by 1. Now, if I cross multiply, or multiply both sides by dx, I am now separating the variables of g and x, or dg and dx. So I would have on my left-hand side dg equals negative 8x to the negative 2 dx. Now over here I've indicated that it's dy. Really we should probably be thinking about it as dx because this is the function g of x. Now either way, whatever you want to think about it is fine, okay? Really, dg is equivalent to dy in these notations here. So, well, we're given that dx is 1/2 or 0.5. So I could put that 0.5 in for my dx. I'm trying to find what the differential of g would be. How far down would g go if x goes over 1/2? Because the diagram here has us focused in on the x value of 2, I'm going to use that value in for our x. And then I'm going to do the computation. If you do that computation, you're going to find that dg equals negative 1. So if I have my graph, if my value of x goes from 2 1/2 farther over, so at 2.5, and I know in my function if I put in 2 into g of x, g of 2 would be 8 over 2, which is 4, and that's shown in the graph as well. So I have the 0.24. What this differentials will do is it will give me an estimate of what my y value would be. It could give me an estimate of what my y value would be, because I now know if this went over an x length of 0.5, the corresponding y length would be going down 1. Okay, so what would my y value potentially be? Well, it would be a good estimate would be a y value of 3. Now that's not really, this 3 isn't really asked for in this particular problem, but it will be coming up shortly. Okay, furthering the